Hello, today I will be presenting on Classful IPv4 networks. In this presentation, I will explain what IPv4 is, how IPv addresses are structured, the different address classes, and why classful addressing was eventually replaced by newer methods. Understanding classful IPv4 networks allows us to understand how early computer networks in the internet were organized. IPv4 stands for Internet Protocol version 4. It is one of the main protocols used to identify devices on a network and allow them to communicate with each other. An IPv4 address is a 32-bit number that uniquely identifies a device on a network. These addresses are usually written in dotted decimal format, which means they are divided into 4 numbers separated by periods. For example, an IPv4 address might look like 192.168.1.1. Each section of the address is called an octet, and each octet can contain values from 0 to 255. This system allows millions of unique addresses across the network. An IPv4 address has 2 important parts, the network portion and the host portion. The network portion identifies which network the device belongs to, while the host portion identifies the specific device on that network. For example, consider the address 192.168.10.25. In this case, the network portion might be 192.168.10, while the host portion is 25, which identifies the specific number specific device, such as a computer or printer. This structure allows routers and networking equipment to correctly send data to the right destination. Classful addressing was one of the original methods used to organize IPv4 addresses. Instead of using flexible subnet sizes like we do today, the address space was divided into fixed groups, called classes. Each of these classes had a specific range of addresses, a default subnet mask, and a different number of available hosts. This address was designed to support networks of different sizes, from very large organizations to small networks. There were 5 of these classes. The 5 classes of IPv4 classful addressing is Class A, which was designed for extremely large networks, Class B, which was used for medium-sized organizations, Class C, which was designed for smaller networks. Class D and E are a little weird. D is used for multicast communication, which sends data to multiple devices at once, while Class E is reserved for experimental purposes and is not commonly used in normal networking. Class A networks were designed for very large organizations. The address range for Class A networks is 1.0.0.0 to 126.255.255.255. The default subnet mask for Class A networks is 255.0.0.0, which means the first octet identifies the network, 255, and the remaining 3 octets identify the hosts. Because of this structure, Class A networks can support over 16 million hosts on a single network. These networks were originally used by very large institutions, such as government organizations or major corporations. An example of a Class A network is 10.0.0.0. In this example, the network portion is 10, because it's the first octet, and the host portion is the remaining 3 octets. This means that a network like this could support thousands or even millions of devices. Class B networks were designed for medium-sized organizations. The address range is 128.0.0.0 to 191.255.255.255. The default subnet mask is 255.255.0.0, meaning the first 2 octets represent the network portion and the last 2 octets represent hosts. This allows each network to support about 65,000 hosts. Class B networks were commonly used by universities, corporations, and large businesses. An example of a Class B network is 172.16.0.0. The host portion of this network is the first two octets, 172.16, and the host portion is the two zeros, the last two octets. This type of network would allow a large organization to connect thousands of devices, such as computers, printers, servers, and other networking equipment. Class C networks were designed for small networks. It's what you normally see in homes or small business networks. The address range is 192.0.0.0 to 223.255.255.255. The default subnet mask is 255.255.255.0. Which means the first three octets, the three 255s, identify the network, and the final octet, 0, identifies hosts. This allows a maximum of 254 hosts per network, which is ideal for small businesses or home networks, like I said. An example of a Class C network commonly is 192.168.1.0. You'll see that a lot. Many home routers actually use the 192.168 range. For example, 192.1.10 might be a computer, 192.168.1.20 might be a phone, and 192.168.1.30 might be a printer. All of these devices are in the same network but have different host addresses. Class D and Class E networks, like I said, are weird. Class D addresses are used for multicast communication. Multicast allows data to be sent to multiple devices at the same time instead of what normally happens, which is sending separate copies of the same data. The Class D range is 224.0.0.0 to 239.255.255.255. Sorry. Class E addresses range from 240.0.0.0 to 255.255.255.255 and are reserved for experimental and research-based purposes. Hence, Class E. Problems with classful addressing. One of the biggest problems with classful addressing was inefficiency. Because networks were designed with fixed sizes, or were assigned fixed sizes, many organizations received far more IP addresses than they actually needed. For example, a company might receive a Class B network with thousands of available addresses, even if they only need a few hundred. This led to a large amount of wasted IP address space and contributed to the shortage of IPv4 addresses, which eventually led to the development of IPv6. A modern solution to this problem is CIDR. To solve these problems, networking moved to a system called CIDR, which stands for Classless Interdomain Routing. CIDR allows networks to be divided into much more flexible sizes. Instead of fixed classes, CIDR uses slash notation, such as 192.168.1/24. This allows network administrators to allocate address space much more efficiently and avoid wasting large blocks of addresses. This is where you start seeing like subnets. In conclusion, classful IPv4 addressing was an important early method for organizing IP addresses on the internet. It divided the address space into 5 classes, which were each designed for networks of different sizes. However, this wasted many IP addresses and helped contribute to the IPv4 depletion. And so now modern networking now uses classless addressing and CIDR instead. Even though classful addressing is no longer widely used, it's still important to understand because it forms the foundation of many networking concepts. Thank you for listening to my presentation on classful IPv4 networks.